In this video, we're going to talk about recommender systems. Recommender systems are software platforms that can help people to discover new content they can potentially be interested in. The main advantage of this is a fast retrieval of personalized content. For example, Amazon Prime Video and Netflix can suggest you movies that you yet didn't see and that you can potentially like. For this video, we are going to focus on one type of recommender system, and this type is collaborative filtering. There are several types available, but for this lecture, we will focus on collaborative filtering only. A collaborative filtering system is a class of recommender system in which the software platform can suggest items based on feedback from users and based on similarity measures. The similarity measures can be based on users or based on items. So imagine a black box. As input, we have a list of users and a list of items, plus some feedback data that can be in the form of ratings, for example, so an explicit feedback, or can be an implicit feedback, for example, in form of page views or time you spend on a page, for example, on Amazon. When you see an item and you want to shop that item, Amazon can record how much time you spend seeing that page. And the output of this software system is a prediction, so a list of possible items that the user can potentially be interested in. There are two main collaborative filtering techniques. These are memory-based filtering and model-based filtering. Memory-based filtering are based on similarity measures, so they highly rely on similarity measures. And they use techniques such as Cosine Similarity and Person Coefficient to determine how much users or items are similar. In a model-based approach instead, the software system uses a model, so it builds a model of the user, for example, and what the user can potentially like. So it uses a more complex approach to determine future observations. And this approach uses methods such as matrix factorization, singular value decomposition, and Bayesian networks. The way it works, the memory-based, is that we basically have a matrix of user and items. So we have users as rows and items are columns. And the value of this matrix are the feedback values. So for example, in the case of a rating system, these feedback values are ratings. As you can see here in the example, we can have, for example, movies as items and users that voted specific ratings for that particular movie. Memory-based techniques can be subdivided into two main categories. So we can calculate similarity based on users, so user-based, or based on items, item-based. Let's take a look at an example. In the user-based collaborative filtering approach, here we have Alice, and we want to estimate if Alice would like item 5 that she didn't see. For example, item 5 can be a movie. We have data about the previous items, and we have data about other users. In the user-based collaborative filtering approach, we are going to calculate item 5 based on similar users to Alice. So we have to look at which user or users are similar to Alice in terms of ratings. In other words, which users have similar ratings to item 1, 2, 3, and 5, and 4, sorry. Based on that, for example, if we have, in this example, user 2 that has similar ratings to Alice, so item 1, Alice put 5 and user 2 put 4, and we have similar ratings for item 2, 3, and 4, so we can assume that user 2 is similar to Alice, and user 2 watched item 5 and voted 5 as rating for item 5. Assuming that Alice and user 2 are similar, we can infer that item 5 will be liked by Alice with a similar rating to user 2, so similar to 5. In particular, user-based approach uses two basic algorithms. One is nearest neighbors over users, and the other one is clustering of users. For the first one, we basically start from the matrix, user item matrix. We compute the similarity between users, and we find users who are similar to Alice. And then we recommend items seen by those users, similar to Alice, and that Alice didn't so. For the clustering, instead, we subdivide users based on groups or clusters. In the item-based collaborative filtering approach, instead, we have a different approach. So basically, we want to calculate if Alice will like item 5. Instead of calculating similar users to Alice, we analyze what Alice voted for items that are similar to item 5. For example, if item 5 is Ace Ventura number 1 and item 4 is Ace Ventura number 2, these two are similar because they are both comedy and they have one common actor, and they are movies of the same series of movies. So we can assume that item 5 will be rated as 4 by Alice. The algorithms for the item-based approach are similar to the user-based approach, but in this case, the similarity is calculated based on items instead of users. How do we calculate similarity? The simplest method is Euclidean distance. For example, here we want to determine how similar is Michael to Claudia in terms of liking movies, for example. And here we have that they have similar ratings for the movie Snake, Superman, and Knight. So we can calculate the Euclidean distance, as you can see here. And we will analyze, for example, for Snake, it will be the difference between what Michael indicated as a rating, so 3, minus what Claudia indicated as rating, 3.5, and so on for other ratings. And at the end, we have a score that indicates how similar Michael is to Claudia. Another method is cosine similarity. So this is an example in which we want to analyze, for example, how similar Joe is to Beck. And in this method, we use basically the dot product to calculate the cosine similarity. A more complex method is the Pearson correlation score. As an example, we want to analyze how much Lisa is similar to Jack. In this case, we measure how well two sets of data fits on a straight line. And by data, I mean the ratings of each of Lisa and Jack, basically. There are advantages and disadvantages of these two techniques, so memory-based and model-based. The memory-based have some problems when it comes to scale the application to 1 million of users or 1 million of items or both. It's easy to create, so that's an advantage, and it's easy to double-check results, but it's very hard to scale, and you can have a lot of the table, the user item table can be sparse. By sparse, I mean that users might not rate some items, and this can create some problems because you're missing data. We have also performance issues when we have a very big data set. For the model-based, it's easy to scale because you actually use matrix factorization, so you factorize a matrix. The advantage is dimensionality. It doesn't have performance issue similar to memory-based, but you have some problems with the inference of latent factors. Let's take a look at model-based. There are three main approaches. One is deep learning, which uses multi-layers of neural nets. Another one is matrix factorization that is commonly used, and it can use some techniques like singular value decomposition, probabilistic matrix factorization, and non-vector matrix factorization. Finally, we have non-parametric approaches which use K and N, that is nearest neighbors. We will take a look only at the matrix factorization for this video. So how does it work? It's different from the memory-based. So in memory-based, we have ratings and can be a value from 1 to 5. In this case, we assume that we assume that customers' ratings, user ratings of 5 movies over 4 users. Basically, we assume that we can express the likelihood a user will like a movie and the ratings of one user over a movie in a 2-dimensional space, as you can see here on the left. And we recommend the movie based on its proximity to, for example, +1 on the epsilon axis, or +1 on the x-axis, or -1 or -1. So -1 will be something like the user didn't like it, of course, and the closest to 1, the more is the likelihood that the user like it or that will like it. So for doing that, we start from a matrix here, item user matrix, and we factorize the matrix. So we start with a matrix A and we factorize it into one matrix for users, one matrix for items, and one matrix for ratings. After that, we calculate a new matrix, that is the prediction matrix, that we can call A star or R star, that is given by the product between the user matrix and the item matrix transposed, as you can see here. So how do we obtain the latent user item matrix? The matrix before is called latent factors or latent user item matrix. A common method is singular value decomposition, which is a linear algebra technique for matrix decomposition. So the steps are these ones. So you identify the matrices. U is the user matrix and V is the item matrix. And basically you focus on important features. So you take into consideration what are the largest singular values. As you can see here in the table, here there is an example here below. And you ignore unimportant values. Then after doing that, you generate new matrices. So U2, sigma 2, and sigma. No, it's not sigma, it's whatever it is, the sum symbol, and V2 matrix. And the resultant X matrix is the matrix factorized. There are some common problems with collaborative filtering. These are the cold start. So you have problems when you add new items or new users to the system. That's because if you add a new item, nobody voted a rating on it. So you are missing data about that item. And in case of a new user, you don't have the new user preferences yet. So you don't know what the user can possibly like and who is similar to. Popularity bias happens when you have an item that is super popular and the system tends to recommend always that item and not other items that are less popular. For example, Harry Potter. Data sparsity means that you have a problem when you have a matrix that with ratings with unknown values. So you have users that didn't vote, that didn't rate a movie, for example, or if you think on Amazon, there are millions of items that you didn't rate. You simply didn't rate. And this is a problem. There is a common workaround to use 0 as a rating, but it's 0. The value of 0 is different than unknown, because, for example, you might like that item, but you just didn't rate it. So 0 will be not the right rating for that items. But for calculating the recommendation, putting 0 in there works. It's an approximation though, so it's not 100% correct, but it works. Scalability, you have problem when you scale the application. This, as we said before, this can be solved for model-based approaches, but it's still there for memory-based approaches. We also have the impact of noise. This happens when you have a family account. So, for example, if you think on Netflix, you share the account with your family and each of you watch movies. In that case, you have noise because your tastes are different than your brother's, and the data that goes into the system are data for one account but with 2 users. So the recommendation won't be right. We also have some human-related limitations. So these less technical but more at a cognitive level. So the first one is abstraction. So the recommender system creates a mathematical model of the user and try to predict what the user will like. If you the reality is more complex than that. Here there is an example. So for example, I watch Ace Ventura 1, 2, and Monty Python. I'm user 2. I'm user 1, and you're user 2. And you watch Ace Ventura 1 and 2, but not Monty Python. So a recommender system will, a user-based recommender system will suggest Monty Python to you because Ace Ventura 1 and 2 are comedy movies. Monty Python is a comedy movie. And we both saw Ace Ventura 1 and 2. So the system assumes we are similar users. But what happens if you don't like English humor? Or you don't like an actor in Monty Python, so you don't like really Monty Python, but the recommender system assumes you like it, and it's very hard to quantify and express mathematically English humor, for example. Another problem is evolution. So users change taste over time, and a recommender system keep track of all those previous decisions you make. So if when you turn a certain age you start liking a different kind of movie and you like, for example, sci-fi before and you're switching towards comedy, the system will still recommend you sci-fi because you like it in the past. There are several evaluation metrics. We won't have time to see all of them here. But the most commonly used are precision, which basically calculate the number of right recommendation over the total number of recommendations. So those that are effectively good recommendations. And the root mean square error and the mean absolute error.